Welcome to Samba Samba. Enjoy the video.
You begin by opening the material editor so you can build a reliable material definition. Create or choose a library. Once done, add a new material entry and give it a clear name. Set the base category to metal, plastic, or composite and enter an initial density in kilograms per cubic meter. This matters for mass and simulation accuracy. Make sure to save to a custom library instead of the default so updates remain organized and reversible. Now populate the crucial physical properties that drive simulation and manufacturing decisions. Input elastic modulus and Poisson's ratio for structural behavior, then add yield and ultimate strengths for failure criteria. Explain why each matters to a specific simulation outcome. Next, include thermal conductivity and specific heat for thermal analyses, and a linear expansion coefficient if temperatures vary. Use supplier data where available. Convert units carefully, and include notes in the material description so you or teammates finish by applying the new material to a representative part and run mass properties to confirm mass and inertia match expectations. If values are off, double-check density and unit conversions, then rerun. Save your custom library and export the SLDMAT file for backups or team sharing. One key troubleshooting tip: if simulations fail or mass is wrong, inspect unit settings and ensure no properties are left blank. Most errors come from inconsistent units or forgotten density entries, so correct those and reapply.
Thanks for watching. Consider subscribing if we helped you.